Hi and welcome to Chemipedia chemistry classes for 11th standard. In this video, I am going to discuss about balancing of chemical equations based on stoichiometric method. Stoichiometric balancing equation, which is also called as trial and error method. Okay, right. So look at the first example. C plus O2 gives CO2. Carbon reacts with oxygen, giving carbon dioxide. The formula of carbon C, oxygen O2 gives carbon dioxide CO2. So now look at the left hand side of the equation. There is one carbon atom and two oxygen atoms, isn't it? Whereas right hand side, one carbon, two oxygen atom. So now this equation is already balanced. And look at the second one also. Sulfur on reaction with oxygen giving sulfur dioxide. Even the second equation also, number of sulfur atom and oxygen atoms are balanced, equal on either side, isn't it? So this kind of equations, what you call it as self-balanced equation. What we call self-balanced equation. Once we write the molecular formula of the reactant product, when the equation itself balanced, then it is called as self-balanced equation. Okay, we go for the third example. Magnesium on combustion in oxygen gives magnesium oxide. So magnesium symbol Mg plus O2 oxygen gives MgO. Now left hand side one magnesium and two oxygen atoms are there. Right side one magnesium, one oxygen. But now first we have to balance oxygen, so that we write 2 before MgO. We write 2 before MgO to balance oxygen number. So once you write 2 before MgO, the number of magnesium atom also becomes 2 on right side. So that left side before Mg we have to add 2 to balance magnesium equal on either side, isn't it? So finally we are getting 2 Mg plus O2 gives 2 MgO. Okay, so this is a stoichiometric equation. Okay, so balanced equation. So a simple equation which is balanced by adjusting number of atoms equal on either side. Okay, right. Now we go for the next example. Example 4. Haber's process. This process is called as Haber's process. It's nothing but formation of ammonia from nitrogen and hydrogen. Nitrogen reacts with hydrogen gas. Nitrogen gas reacts with hydrogen gas, giving ammonia gas. Okay, so I write formula N2 plus H2 gives 2NH3. Okay, right. Now left side there are two nitrogen atoms, isn't it? Right side one nitrogen. So to balance nitrogen, I add 2 before NH3 on right hand side. Okay, so that the equation becomes N2 plus H2 gives 2 NH3. But nitrogen is getting balanced. When you introduce 2 before NH3, now the hydrogen becomes 2 into 3, 3 hydrogen atom. But left side you have only 2, isn't it? But so that to balance hydrogen, now I am adding 3 before H2 on left hand side. But now the hydrogen becomes 6 on either side. So now finally you are getting a balanced Haber's process equation. N2 gas plus 3H2 gas gives 2NH3 gas. Okay. Now example number 5. Na2SO4 plus BaCl2. Na2SO4 reacts with BaCl2. Sodium sulfate reacts with barium chloride solution, gives a precipitate of barium sulfate with byproduct sodium chloride. Okay. Now, so just we have written the formulas. Sodium sulfate formula, barium chloride, barium sulfate, NaCl. Now, the barium is balanced on either side, even sulfate portion also. But look at sodium. Left side there are 2 sodium atoms, but right side only 1, isn't it? But now to balance sodium atoms, I introduce 2 before NaCl on right hand side. Okay, but now the equation becomes Na2SO4 plus BaCl2 gives BaSO4 precipitate plus 2 NaCl. Once you introduce 2 on right hand side before NaCl, the number of chlorine atom becomes 2. So left side also have 2 chlorine atoms. So automatically even the chlorine also getting balanced. Okay, so right, now we go for the next example. Example number 6. Fe plus 2H2O. Fe plus 2H2O gives Fe3O4 plus H2. Iron reacts with water, gives an iron oxide Fe3O4 plus H2. Right, now look at the number of iron atom on left side. Left side there is only one iron atom, but right side there are 3, isn't it? Fe3 is there, isn't it? Similarly, right side oxygen is about 4, but left side only H2O, only one oxygen. But now we have to balance iron and oxygen first, isn't it? So that to balance iron, I add 3 before Fe on left hand side. Similarly, to balance oxygen, I add 4 before H2O on left hand side. So left hand side, before Fe, I add 3. Before H2O, I add 4, isn't it? Now the equation becomes 3Fe plus 4H2O gives right side as is Fe3O4 plus H2. Okay, right. Now iron, oxygen are getting balanced. Now we have to look at hydrogen. 4H2. There are 8 hydrogens on left hand side, but right hand side, only 2. This you have to make it as 8. So that I add 4 before H2 on right hand side to balance hydrogen. Okay. But now this is a complete balanced equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Next question number 7. FeSO4. Ferric sulfate plus ammonia plus water gives ferric hydroxide FeOH thrice plus NH4 twice SO4. NH4 twice SO4, which is nothing but ammonium sulfate, isn't it? Right. Now, so look at the number of iron atom. Look at number of iron atom on either side. Left side there are 2. Right side only 1, isn't it? Right. Similarly, sulfate portion. Left side there are 3 times thrice SO4 sulfate ion, but right side NH4 only 1 time, isn't it? But now first I introduce 2 before FeOH thrice on right hand side, as well as 3 before NH4 twice ammonium sulfate on right hand side. I introduce 2 here to balance iron and 3 here to balance sulfate ion. Okay, so now I am getting an equation. Left side is written as such, right side 2 is introduced before ferric hydroxide, 3 before ammonium sulfate. Okay, right. Now, so when introduce 3 here, so the number of nitrogen becomes 2 into 3, 6. But whereas left side, you have only 1 nitrogen, isn't it? This you have to make it as 6. So I'm going to add 6 before NH3 on left hand side to balance nitrogen atom, isn't it? So now it becomes Fe2SO4 thrice plus 6 NH3 plus H2O gives 2 moles ferric hydroxide and 3 moles of ammonium sulfate. Okay, right. Now I count the hydrogen on either side. Okay, now I'm going to balance hydrogen. So left side there are 18 hydrogen atoms and here 2, isn't it? So there are 20 hydrogen atoms on left hand side. Look at right side 3 into 2, 6 hydrogen here. Then 2 into 4, 8 into 3, 24. 24 plus 6, 30 hydrogens are there. So totally there are 30 hydrogens on right hand side, but left hand side 18 plus 2, there is 20 only there. Okay, this alone 18. When you make this as 12, when you make this hydrogen number as 12, 18 plus 12 will become 30, isn't it? So that I introduce 6 before H2O. I introduce 6 before H2O on left hand side to make this as 12 hydrogen to balance hydrogen equal on either side. Okay, right. But now finally the equation becomes Fe2SO4 thrice plus 6 NH3 plus 6 H2O gives 2 FeOH thrice plus 3 NH4 twice SO4. This is a complete balanced equation, okay, of the reaction between ferric sulfate and aqueous ammonia. The next one, potassium permanganate KMnO4 reacts with H2SO4 gives K2SO4 potassium sulfate plus MnSO4 manganese sulfate H2O water and oxygen. Okay, right. So now let us see how to do balancing of this reaction. Okay, right. Now, so left side potassium is about 1 time, whereas right side there are 2 potassium, isn't it? So now to balance potassium, I add 2 before KMnO4 on left hand side. So now it becomes twice KMnO4. It becomes twice KMnO4 remaining as such. Okay, right. When you introduce 2 before KMnO4, the number of manganese becomes 2, isn't it? Whereas right side there is only 1 manganese. So to balance manganese, I add 2 before MnSO4 on right hand side. Okay, add 2 before MnSO4 on right hand side to balance manganese. But now this becomes twice KMnO4 plus H2SO4 gives K2SO4 plus here I am introducing 2 MnSO4 plus H2 and O2. Okay, right. Now look at the sulfur atom on right hand side. Here 1 sulfur, in manganese sulfate 2, but totally there are 3 sulfur atom on right hand side, whereas in left hand side we have only 1 in sulfuric acid. But now we have to balance sulfur, so that to balance sulfur I add 3 before H2SO4 to balance sulfur atom. Okay, but now it becomes 3H2SO4. The remaining as such, isn't it, right? Once you add 3 before H2SO4, the hydrogens becoming about 3 into 2, 6 hydrogen atoms. Whereas right hand side only 2 hydrogen atoms are there, isn't it? But now this you have to make it as 6 hydrogen atoms, so that I am going to add 3 before H2O on the right hand side for balancing hydrogen. Okay, but now it becomes 3H2O, isn't it, right? Now finally I go for balancing oxygen. So look at the number of oxygen on left hand side. So here 8, here 12 oxygen. So totally there are 20 oxygen atoms on left hand side. Whereas right hand side, potassium sulfate 4, manganese sulfate 8, and in water about 3, isn't it? And oxygen 2. So 4 plus 2, 12, 4 plus 8, 12, plus 3, 15, plus 2, 17. So this alone 15. When you make this as 5 oxygen atom, when you make this as a 5 oxygen atom, 15 plus 5, it will become 20. Now the oxygen will be balanced, isn't it? So that what I am going to do is, I am going to introduce 5 by 2 before O2 to balance oxygen atom, because one O2 is nothing but 2 oxygen atom, isn't it? 1 oxygen molecule is equal to 2 oxygen atom. 5 oxygen molecule is 10 oxygen atoms. 5 by 2 oxygen molecule is 5 oxygen atoms. So that I am introducing 5 by 2 before O2 on right hand side to balance oxygen. Okay, right. So now it becomes twice KMnO4, thrice H2SO4 gives potassium sulfate plus twice MnSO4, 3H2O, and I introduce 5 by 2 before O2. Okay, right. Now this is a balanced equation, but normally in a stoichiometric equation, the number of moles should not be in a fractional number, so that this 2 has to be cancelled, so that I multiply all the substances by 2, so that it becomes 4 KMnO4 plus 6 H2SO4 gives 2 K2SO4 plus 4 MnSO4 plus 6 H2O plus 5 O2. Okay, now that when you multiply this by 2, the denominator 2 gets cancelled, so you get only 5 O2. Okay, this is a balanced complete equation. Okay, right. Look at the last example. Potassium permanganate KMnO4 reacts with hydrogen chloride gas, giving potassium chloride and manganese chloride, water and chlorine. Okay, right. Now let us see how to balance this. Okay, right. Now look at number of oxygen. Potassium is balanced on either side, even manganese also. Okay, now we have to go for oxygen. There are 4 oxygen atoms on left hand side, but right hand side only 1, isn't it? So that I introduce 4 before H2O to balance oxygen atom. Okay, but now it becomes H2O becomes 4H2O, remaining formula as such. Okay, right. When you introduce 4 before H2O, now hydrogen is becoming about 4 into 2, 8 hydrogen. But left side only 1 hydrogen, isn't it? So now here you have to introduce 8. So add 8 before HCl on left hand side for balancing hydrogen, isn't it? But now this HCl becomes 8 HCl, remaining as such, isn't it? Right. Now look at the chlorine. Last element, what you have to balance is nothing but chlorine, isn't it? Left hand side there are 8 chlorine atoms, whereas right hand side in KCl1, MnCl2 2, 3 plus last Cl2 5, isn't it? Right. So that this together 3. Now when you make this as 5 chlorine atom, 5 plus 3, 8, so that chlorine will get balanced, isn't it? But if you introduce any number before either KCl or MnCl2, then again you have to go for balancing of potassium and manganese, so that without disturbing potassium chloride and manganese chloride, we are introducing some number before Cl2 and we balance the chlorine atom. Okay, right. Now this together 3, this is supposed to become as 5, 3 plus 5, 8 chlorine will be balanced, isn't it? So that what I am going to do is I am going to add 5 by 2 before Cl2, because 5 by 2 Cl2 is equal to 5 Cl. Okay, 5 plus 3, 8. But now I add 5 by 2 before Cl2 on right hand side, isn't it? Now the equation is K1O4 plus 8 HCl gives KCl plus MnCl2 plus 4 H2O plus 5 by 2 Cl2. Okay, this is what I have introduced. 5 by 2 Cl2 is equal to 5 Cl. Okay, right. 5 plus 2, 7 plus 1, 8. Here 8, so chlorine is getting balanced. Okay, but as I said, discussed already, the number of moles you should not write in a fractional number, so that this 2 has to be cancelled, so that all the substances are multiplied by 2, isn't it? So multiply by 2 on both sides. So the final balanced stoichiometric equation is twice K1O4 plus 16 HCl gives twice KCl plus twice MnCl2 plus 8 H2O plus 5 Cl2. Okay, right. Thank you.